Hey, welcome back. Today's video is actually going to be specifically just on the quotient rule. We've already had a video about the product rule. And now we're going to be looking at just this quotient rule is all we're going to be looking at. So what you do when you've got two functions, and you can see here, function u and function v, and we're trying to divide those two functions. So let's just go straight to do one. We've already done that here. This was a product rule. We got two functions being multiplied. Another product rule, although it was way easier than that. But anyway, another product rule. So where is Mia quotient rule? Ah, there is Mia quotient rule. So what I do with this quotient rule is this. I'm going to make this top u, and I'm going to call this bottom function v. And that's what gets me ready to do this. So just like when you're doing a product rule, the first thing I'm going to do is I'm just going to walk over here and write y or u equals x squared plus 1. And I'm going to take the derivative of that function, which would just be 2x. And now I'm going to do the same thing. I'm going to write function v is equal to x squared minus 1. And therefore v prime would just be 2x. Okay, so we're off to a good start. And man, I love this one. This one's so easy. Matter of fact, it's so easy, we didn't really even have to work it as a product rule. Or excuse me, almost messed up, a quotient rule. Well, just like with the product rule, let's write our formula down. U prime v minus uv prime over v squared. So very similar to that product rule that you've already been using. And now all it is a question of substitution. U prime is 2x, so I'm going to go 2x times my function v. I have no idea where that x just, or that 2 just came from. Let's see if I can erase that. So v is x squared minus 1 minus u, which is x squared plus 1, times v prime, which is 2x. Hey, this is fun so far. I like this. Over v squared. Well, v is x squared minus 1. So I'm going to square that function from a bottom. And now this is pretty much just all we're going to do is do some simplifying here. And this problem is going to be over. So I'm going to do a little something here. I'm going to distribute up here at the top. So that would be 2x cubed minus 2x. And let's see, on the other side, it would be minus 2x cubed. And then minus 2x. And all that's over my x squared minus 1 square. Hey, check this out. 2x cubes are gone. And so I actually end up, when all this is said and done, with, what have I got here? Negative 4x over x squared minus 1 square. Bam! And I've got this one done. All right, good deal. So that's all there is to do in the quotient rule. It's really not that much harder than anything we've done. Now I do got an idea. Let's switch over for a second. Is there a way we could work this one without making a quotient rule? Could we turn it into a product rule? Well, yeah, we can. All we'd have to do is rewrite it. You just got to remember something. Anytime I want to bring something off this bottom, I know how I can rewrite it. So I can rewrite this problem to be x squared plus 1 times x squared minus 1 to negative 1. And now I've got a product rule. So I've took a quotient rule and made a product rule out of it. So there's my function u, and here's my function v. And let's see if we can just do this. Same rules apply. U equals x squared plus 1. So u prime is 2x. So far, so good. Now, v, look at what we've got. X squared minus 1 to the negative 1. That means this problem is a chain rule question now. So if I want to take this derivative, I need to multiply by negative 1. So it'd be negative 1 times x squared minus 1. Now I'm going to subtract 1. So that gives me negative 2. And then I'm going to multiply by the derivative of its guts, the derivative of the inside. And the inside of this is 2x. Now let's see if we can't clean this up and make it presentable. So this looks like it's going to be negative 2x over, what have we got here? X squared minus 1 square. Well, we've done this, so let's apply our product rule now at this point. Extend you page. Hey, come back here. I just dropped my pen. It's a digital pen. Thank goodness it's attached by a cord. So let's see if we can't do this. Product rule, u prime v plus u v prime. So let's just substitute. U prime is 2x times v, which is, v is x squared minus 1, x squared minus 1 to negative 1, plus u, which is x squared plus 1. Where am I? Now v prime. V prime is, good night, negative 2x over x squared minus 1. Yeah. Oh, you turned out to be ugly, didn't you? You sorry, mean-spirited thing. So can we somehow or another try and simplify this thing away from what it is? Well, I'm sure we can. Let's see, this becomes 2x over x squared minus 1. This one over here, let's see, what does he become? Plus, who are you? You would be negative 2x cubed. I think you're seeing though why we like, or 2x, yeah, 2x cubed minus 2x over, where are we? X squared minus 1 square. Hey, we can still do this. I need to, how can I add this? Now see, we just walked off the deep world of mathematics here. Look at what I want to add. I need to find a common denominator. Good grief. Hopefully you're seeing why the quotient rule comes in handy. If I need a common denominator between these two functions, I'm going to have to take this first function. I'm going to have to take this and multiply top and bottom by x squared minus 1. Hey, this is fun. I'm having a ball. So this would be 2x cubed minus 2x over, check this out, x squared minus 1 square plus negative 2x cubed minus 2x over x squared minus 1 square. And now if we look, holy cow, and look at what we get. Negative 2x becomes negative 4x over x squared minus 1. And we've got the exact same answer. But I hope you can actually look at this and respect how much cleaner at least the algebra was by using just a quotient rule. So anyway, now sometimes you might actually simplify it by trying to make a product rule out of it, but I don't think we simplified this one at all by doing the product rule. Matter of fact, I wonder how many people were actually paying enough attention to try and get their common denominator on that bottom down here. So anyway, a good little mathematical exercise for us there at least. All right, so let's go and see if we've got another quotient rule question. I want to use that quotient formula again. Now, I'm going to turn this one into a quotient rule. Do I have to? No. This one would actually be a very easy chain rule question. And if you don't believe me, heck, let's go prove it for a second. Could this be a chain rule question? Well, yeah, all I'd have to do is rewrite it to look like this. X plus 1. And now it's a chain rule. We can do this one in a second. That'd be negative 2, x plus 1 to the minus 2 times the derivative of the inside. Well, the derivative of x is just 1. So this would be negative 2 over x plus 1 square. Bam. I didn't even use no product rule, no quotient rule. Well, I want to go back and try and work this as a quotient rule. And if I'm going to work it as a quotient rule, then I'm going to have my two functions, a u and a v. But what makes this so easy is going to be the derivative of u. If u is 2, then u prime is just 0. Well, let's go back and see what we can't do with that guy. Let's work him for real over here. So here we are. I got him ready. So let's do it. The top, I'll call u, the bottom v. So I'm going to say that u is equal to 2. So u prime is equal to 0. So there's my derivative. And now I'm going to do v is equal to x plus 1, and v prime is equal to, wow, this problem is awesome. The derivative of x plus 1 is 1. So now we'll go in and we'll do our quotient rule. So quotient rule says u prime v minus u v prime over v square. Oops, v square, not v prime. All right, let's plug in our numbers. So this would be 0 times, which there's no sense of even writing this, but I will, x plus 1. So it'll all be 0, minus u, which is 2, times v prime. Oh, look at that, v prime is 1, over v square, which is x plus 1 square. Well, let's look. All that cancels, and we're left with negative 2. Check it out, negative 2 over x plus 1 square. Let's see, how'd that compare to our answer from the other one that we did? Oh, it is the exact same answer by doing the product rule or the quotient rule. Well, good. I was kind of hoping that since I made it a quotient rule example. But anyway, you've got the idea. You should be able to get into and work these problems now. So anyway, good luck and mazel tov. I don't even know what that means. I doubt anyone watching this video. Well, hey, tell you what. Nah, by the time you email me, I'll probably already know. But anyway, thank you for watching and salutations. Bye-bye now.